Hey everybody, this is Larry. This is me going Q3 of the weekly contest 370. Maximum score after applying operations on a tree. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So there are a couple of critical points about this one. If you follow my Leetcode or Discord enough, you'll know that I complain a lot about the tree graph. Oh, sorry, the star graph on a tree. Or a star tree maybe. But basically, it's just like one node that's spread out to all of them. And if you do the caching in a bad way, this could become n squared. So, but this tree is rooted at 0. And because of this, there's only one direction for every node. So that makes it okay, even for a star graph. But yeah. But otherwise, this is I would say basic dynamic programming problem. Basic nowadays. I think this is kind of tricky, to be honest, especially for Q3. I thought it was tricky. It took me about 10 minutes, which is, which I consider tricky. But basically, you can think about it instead of, all these things, all these words. The way that I think about it is that you have to leave one node behind on every path, right? So instead of thinking about what to kind of take for your points, think about which to leave behind as your points. Maybe you can think about it that way, and once you do that, then every node only has, and if I go top down, every node, and oh yeah. So during the virtual contest, I was thinking, okay, is it easier to do top down or bottoms up kind of thing? But for me, I just thought it was easier to do tops down, and from the top down, from the root down, you only have two constraints, right? One is that, okay, one thing to notice is that if you have a node and you take this node, or sorry, you keep it on the tree and don't take it, all the subtrees are good, right? Because no matter what, from the root to this node, everything underneath of it is covered by you not taking this node. So because of that, that's pretty much the idea, and you kind of recursively figure out the scenarios. For me, the scenarios were not trivial, but I guess it's figure outable, so which is good enough. So we'll go over it first. First of all, we convert the adjacency list. Oh, sorry, the edge list to an adjacency list, and that's what I have here, right? After that, we calculate straight down. So this node, which is, let's just say 0 to n. Or n minus 1. Parent is also 0 to n minus 1. But the key thing to note is that for this parent, like I said, you only have one parent because there's only one root. So this basically rolls into the node. For every node, there's a unique parent. And then needed is true or false. So, so this, yeah. Yeah. So basically, you could break it down to whether we still need to, and this is whether on this path downwards, we still need to take the node, right? But we still need to leave a node. So if this is not needed, meaning that, earlier on a tree, we already left the node behind, then we could take everything on the down the path for free, and this is basically the recursion of it. It's just a standard depth first search. I don't know why I don't call it go. Just find the children and then keep going down, saying that you don't need a tree, and you just rooted it, or you sum it, and that's it, right? If you do need to leave a node, then we look at it, right? If we leave the node behind, then we don't take the current node, but we're able to take all the children nodes. So then that's a very nice sentiment. Yeah, that's just very nice. And if you do take it, then you get the node of the value of the node because you took it for points. But then and remember, this is needed is equal to true, right? So in that case, all the children, you still need to take one from his path, and that's basically what it does. And then I added one more thing, which is that if the children is equal to 0, that means that this is a leaf node, right? Leaf node. So if you don't take it, then this has negative infinity value, because that means that you ran out. You have to take this one, basically, is what it's saying. And then after that, you take the max of take and leave, and that's pretty much it. Like I said, there are only O of n inputs all needed. The way that I always say this is time complexity is equal to time per input times the number of inputs, right? Number of inputs, it's obviously going to be O of n, but time per input can also be O of n. Question mark, question mark, question mark, right? Well, it turns out that because if you look at all these, like for u and v, right? For u and e of node, if you sum up the entire thing, and because this is a tree, there will only be at most n edges, right? That means that the sum of all the for loops will only be O of n. So therefore, yeah, per one core could be O of n, but all of them combined is also O of n. So this means that the total complexity, it's going to be O of n. Remember that, or O of 2n, which is O of n, suppose. Yeah. And also O of n space, that one's easier to figure out. But yeah, that's pretty much all I have for this one. It's a very tricky problem to get right, so definitely be careful. But once you be careful, it should be okay, hopefully. But yeah, I think that's all I have for this one. Let me know what you think. Let me show you the top again, and then show you the calculation function with the core. And that's pretty much all I have. So yeah, stay good, stay healthy. Oh wait, no, wait. Yeah, you can watch me try to solve it live during the contest now. Let's see if I made a mistake anyway. Okay. Yeah, I just kind of overcomplicated it. All right, maximum score after applying operation is on a tree. Okay, you have a tree neutered at 0, 2D integer array, the edges, okay, of the tree. Pick any node I, okay, add value sub I, and then set to 0. Tree is healthy if the sum of the values from with any, okay. Okay. That means basically what is it basically? Basically, you're trying to keep it healthy, and the way that it is healthy is if a node for everything is 0. Okay. Okay, so can we do, is it DP? Basically, what are we, so basically it's either that this particular node we have to think of the opposite is what I'm trying to do. Basically, if you keep this node, then you get to sum up. Okay, let's say we keep this node, then obviously the subtree, fine, we got to keep all the score. How do we propagate that up? What is the brute force memo thing? Okay, that means that basically we either keep, if we keep, so we go up, down, right? So that means that we already got it, then we sum up everything on the subtree. Okay. Otherwise, if we don't do it, then we have to individually calculate the paths. Right? This is kind of tricky to think correctly, to be honest. But I think on node and n is fine, but I mean something like that, but I'm trying to think precisely. So okay, let's say we take 0. Let's say we do 0, then I'm set. Okay. So okay. This is a medium. Wow. And the heart is just a regular heart. Okay. Something like this, right? Maybe. Not done node. Whoops. So if not, so if node is none, then we just return 0 probably, right? Well, if required, yeah, maybe that's a weird case anyway. Okay, so let's say there are two cases where we take and don't take, but I'm trying to think for what that means, right? So if we already taken it, right? So if required, or maybe needed is a better word, I don't know. That means that we still need to finger thing. So if not needed, then we just kind of am I going to do that? I mean, I'm trying to be sure that no, each node can only do it twice. I'm trying to think about the start diagram one, which we've run into a lot of issues in the past, but no, this can only record twice for each node, so it should be good. Okay, so if not needed, if this is not needed, we just kind of, oops. Okay, fine. For you, we and edges, ye of you. We're setting the adjacency list. Right, and then now if this is not needed, then we just go through it, right? So total is equal to 0. For total is equal to no dot value, and then for u in e sub. Oh wait, why did I think it's a node? Whoops. So yeah, total is equal to y sub node, right? And then for u, then we add calc of u needed and not needed, so that means this is false, right? And also if u is not equal to parent, right? I guess I just left out parent. I'm so like, but there's only one parent because there's a rooted tree, so it should be okay, right? And then we return total. I know I'm doing a double negative here, kind of, but I think this is the more base case. And then now if it is needed, then we either take this. So if not needed, you always just take everything because does that make sense? So otherwise, you can take this, take, right? So we take, then take is equal to 0. Y use up node, and then take. I think it's just this too. So then now, yeah, right. So that's take, and then leave. What does leave mean? Leave means that we. Wait, what does take mean again? Maybe I can mix them up. So take means we take all the values. Okay, fine. If we need to leave one behind, then and we leave. Oh no, I confused the take. So I think this is leave. So leave is equal to 0. And then now we take all the ones behind. Okay, fine. But if we do take this one, then what happens? Then all the other ones in the node will still have required. Right? Yeah. Basically, if it's true, then you have to take, because, or if you take it, this is mostly right, but I'm missing an if statement somewhere. This is pretty hard for medium maybe, but I don't know. Okay, so this is needed. So then we already took it, but here we're taking it, so the children needs to be taken. We have to do a leaf node thing, right? So yeah, yeah, so children is equal to 0, and then if children is equal to 0, that means this is a leaf node. Then tick is equal to negative infinity, because we're forced to leave it behind, basically. Okay, maybe that's good enough of a hack. Let's see. What am I missing? Of the parent. How am I so sloppy? I think I changed that definition as well, but still, thought I could have done it. 1140. Let's give it a submit. Hopefully we don't mess up too much. Okay, good. That was kind of hard for Q3. How am I doing in time? 46, not bad, not fast, but okay. I mean, I had the idea, but it's just kind of so many things to think through. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.